All right, everybody. Hello. Hope you're having a good day out there. I'm Thomas. Welcome to my channel. I do educational videos. Today we're continuing a unit on the reciprocal system of theory, a theory that was developed by Dewey Bernard Larson back in the 20th century. He died back in 1990, and the theory has been updated more recently by the people at the RS2, spearheaded by Dr. Bruce Perrett, who also most recently died back in, I think, 2020. And KVK Nehru, Gopi Krishna, and both of those people have PhDs as well, and other people who have contributed. And so the basics of the theory is that the universe, it's the universe of motion. The universe is made out of motion. And motion is the relationship between space and time. Space and time are the same, only that they are reciprocals of each other. And when they are put together in a fraction, a ratio, that constitutes motion. And there are a whole lot of different kinds of motion out there, and they correspond to the different kind of scientific entities that we're familiar with, like mass. Mass is time to the third power over space to the third power. Or energy is time over space. And, you know, we probably recognize that acceleration is space over time to the second power. And, you know, impulse is time to the, I believe impulse is time to the second power over space. Anyway, it serves as a very good way to check the fact that you can assign those time, just specifically time space. You can get rid of the MKS system and just assign time space units to all physical quantities, and then you can plug them back into the equations that you've been using for hundreds of years for things like gravitation and you know, whatever equations you have in terms of atomic, you know, properties, the basic properties of matter, and you can make sure that the units check out. So that is another great thing about Larson's system, is that it you can check it, and at least to a certain extent. Now we're going through one of his speeches, or a talk that he gave back in 1986, just a few years before he died, when he was at age 88. And this is a talk called The Deductive Development, Outline of the Deductive Development of the Reciprocal System. So in this paper, he's basically going through his thought process. And, you know, he starts with that initial postulate. You know, the universe is made out of space and time. The universe is made out of motion. Motion is the relationship between space and time. Starts from there. If this, then that. If this, then that. And then if this, then that. So it's basically just a deductive development. Now, he does say that he had an inductive phase of the theory for the first 20 or 30 years, where he had to, you know, kind of, instead of, you know, going step by step, it was more of a, you know, kind of more intuitive, and going from specific to general process. But by now, the way he developed the theory, that's how he came to the theory. But the way he developed the theory is through this deductive process. And, you know, when you use the induction, you have to have both the conclusion, and then you have to also verify it. The deductive development doesn't require that level of verification. Okay, this is the ninth video, I believe, on this deductive development. So if you want to really understand this, you're going to need to go back and start over. There's, these videos are approximately 22 minutes. And, if you really want to understand it, you need to go back to the beginning. But I'll try to salvage the whole thing here, starting with number 74. This introduces a new situation, the existence of competing structures. The aim of our development of the consequences or of the postulates of the theory of the universe of motion is to determine what can exist in that theoretical universe. Thus far, we have been able to identify an existing feature of the observed physical universe corresponding to each of the entities and phenomena that we have found that can exist in the theoretical universe. From now on, we will have to consider the possibility that the existence of certain structures may preclude the existence of competing structures. The result of the competition in each case is a matter of relative probability. Where the probabilities are nearly equal, the structures may coexist. Otherwise, the structure that is most probable in a given set of circumstances is the only one that exists under those circumstances other than momentarily. Okay, number 75. The double rotational structure is more compact and therefore more resistant to disruption than the equivalent single structures. This gives it a sufficient margin of probability to preclude the existence of any significant quantity of the competing single structures, unless external forces intervene. Number 76, we identify the double rotational combinations as atoms. The combination 1/2-1/2-1 has a total net rotational displacement of 2 and is excluded by what we just read there. The 2-unit magnetic structure 1-1-0 and its positive derivative M1-1-1, which have net displacements of 2 and 3, are likewise excluded for the same reason. But the negative derivative M1-1-1 can exist as a particle, since its net displacement is only 1 unit. We identify it as the proton. A double rotating system with only 1 net unit of displacement can be formed by a combination of a rotation of the proton type, M1-1-1, and a rotation of the neutrino type, M1/2-1/2-1. We identify this combination, which is M1/1/2-1/2-2, as the mass 1 isotope of hydrogen. Since the second rotation has a net displacement of 0, the probability difference between this double structure and the equivalent single structure, the proton, is small. These structures therefore coexist under appropriate conditions. Now, this brought out a footnote from Bruce Perret, and he says the neutrino has a free dimension and is thus carried by the progression, whereas the proton is gravitating against the progression. This combination will disintegrate in 1 natural unit of time unless the neutrino is charged, trapping it inside the time of the proton. he's basically mapping out here the mechanism for isotopes, calls it magnetic charge, and or gravitational charge, I'm sorry. But that is probably for a later time. So anyway, here we are back again, number 80. Because of some significant differences between atoms and subatomic particles, we will use a different system of notation in representing the atomic combinations. This notation will show the total speed displacement in each dimension, including the initial non-effective unit. Will use a double unit and will omit the letter symbols M and C, which are unnecessary when the initial unit is included. Okay, just recall that initial unit is coming from the progression of the natural reference system, which is always there and which is moving everything apart. And so that initial progression needs to be nullified or overcome before you even can get started. Okay. Number 81. To convert the rotational displacement of the mass 1 hydrogen atom from the subatomic notation m 1.5 dash 1.5 dash -2 to the atomic notation, we divide by 2, obtaining 1 dash 1/2 dash -1, and then add the initial unit, the result being 1 1/2 dash 1 dash -1. The effective net displacement in terms of the double unit is 1/2. And, you know, that is Larson again kind of messing around with his notation. I think I skipped one here. Okay, I did skip number 79. We're going to go back here. If the cosmic neutrino type of rotation C 1/2 dash, or C -1/2 dash -1/2 dash 1 is substituted for the material neutrino type of rotation in this double structure, the combination has net total displacement of m 1/2 dash 1/2 dash 0. We identify it as the neutron. And Perret's footnote then says, the neutron does not require the cosmic neutrino to be charged, as the cosmic neutrino is being carried by the temporal progression, which is outward in time and therefore inward in space, the same direction as the gravitating proton. Okay, now going back to number 82. And here again, you can kind of see that Larson is really getting himself into problems just with his notation. He probably would have benefited from, you know, taking 6 months or something like that, and taking away from his research and revamping his whole notation for everything once he had kind of developed the theory, because it's just very hard to follow his theory based on the kind of notation that he has. He's trying to make things simple, but I think he's appealing to a certain audience that is maybe more scientifically rigorous, but at the same time is utterly confusing. And if he would have tried to maybe kind of relate this stuff to just a general intelligent audience, he might have been able to come up with better forms of notation. But on the other hand, maybe he's leaving that whole enterprise for people like us who come along later, see the whole picture, see his whole theory, and maybe we can revamp his notation to make it less confusing, because it's kind of there's just an easier way to present this. I don't know exactly what it is yet. Hopefully I'll work on that. But he just brings a great deal of confusion to the theory in the way that he presents it. I think Bruce Perret did a much better job of presenting it. And nothing against Larson, again, because when you're the developer of a theory, of a paradigm-shifting theory, you have to develop your own language for it. The words don't exist in many cases, or if they do, they exist in a different context. So you have to come up with a different language, and that's a tall order, especially for somebody who doesn't specialize in that kind of thing. And oftentimes it does require somebody to come along at a later point who can kind of see the big picture. You know, Larson is trying to fill in the picture, and it's hard to have to expect him to, you know, kind of fill in the picture. You know, he's not going to be able to put it on a silver platter for you. You know, he's struggling just to develop it himself. You know, it's going to take people later on who can put it on a silver platter, who can see it from above. Larson is in the muck, you know, trying to sort it out. You know, he's down in the dirty part of it. Now that he's done this, other people can come along and, you know, clean it up. Okay, now number 82. An additional single unit of displacement brings the total to 2-1-1. We identify this combination as the mass 2 isotope of hydrogen. This is the first of the complete two rotation combinations, those with effective rotational displacement in both rotations. It is therefore given atomic number 1. Okay, so atomic number 1 is the mass 2 isotope of hydrogen. The mass 1 isotope of hydrogen is classified as a subatomic particle. And of course, the mass 1 isotope of hydrogen is the one that we're familiar with. And the mass 2 isotope is called deuterium. Now, Perret has a couple footnotes here. The single unit displacement of 1/2 is the net effective displacement for a double unit. And then he also says deuterium. In the reciprocal system, deuterium is the first atomic element, Z = 1, and not an isotope of hydrogen. The neutrino is not a full double rotating system, making hydrogen subatomic. And subatomic particles do not have isotopes because they are an atomic property. Tritium, which is the 3 mass of hydrogen, would be the first isotope of deuterium. So hydrogen 1 is a subatomic particle. Hydrogen 2 is atomic number 1, and hydrogen 3 is the first isotope of atomic number 1. Okay. Now, number 83. This will be the last one. One positive displacement unit on the atomic basis added to mass 2 hydrogen 2-1-1 neutralizes the negative electric rotation and produces 2-1-0. 2-1-0. We identify this combination as helium, atomic number 2. Okay, now just one more note here. It seems like his notation is more complicated than the legacy science. Legacy science just has, okay, hydrogen is 1, helium is 2, lithium is 3, and so on. And he's got these 3 number combinations, 2-1-0, 2-1-1, and so on. For for every atom, he's got 3 numbers. But what comes out in basic properties of matter, and even probably in this presentation, is that he uses those numbers to calculate all of the basic properties of matter. So, he uses those 3 numbers in different permutations, different combinations, to calculate things like the melting point and the boiling point and the compressibility and the specific heat and the interatomic distance. All of those things are calculated right from those numbers. So it seems complicated, but then once you really get down to it, those numbers are extremely useful. He theoretically derives these equations from those numbers. Okay, well, thanks for tuning in. Have a great day, and study up. Don't get discouraged, and we'll keep moving forward. Later on.